Because you can ask one question a day doesn't mean you have to. Just for once, you could sit. Oh, hi. Sorry, I didn't see you there. You must have snuck in. Allow me to introduce myself. My name is Mr. Marshall, science teacher in absentia. Because I'm not here. I do have an assignment for you today. You should have this handout ready to be handed out to you with a couple of the motion graphs that we've done before. Velocity graph and acceleration graph. They're going to be graphing some specific scenarios using this. I am calling it a hover ball, although it is not a ball, and its hover abilities are somewhat limited. Ideally, when the fan on the bottom is turned on, it will both give you a dazzling light show and it will hover only centimeters above the ground though. It will not hover in mid-air, so you should be careful about that. It will simply fall. These should be located in the back of the classroom where you'll put them back when they're done. Make sure you turn them off. I'll leave some batteries just in case you all get very excited about running it during this lab. What I want you to do with it. So you'll get back with your lab groups, groups of about 4, like usual. You'll take one of these hoverboards, balls, and you're going to do this scenario either in the classroom or hopefully you'll be able to go out into the hallway in the Lemon Lounge and you'll just do the scenario. With the fan on, boom, apply a one-time force. So you'll just give the hover ball a push. Your origin will be before the push. So on this horizontal axis, you'll start right here before the push. So before the push, nothing's probably happening. Once you push it, there will now be some velocity. And I want you to continue graphing for a few seconds after the push. It is qualitative, like when we did the basketball toss. Turn that velocity graph into an acceleration graph. How did the push and the change in velocity turn into acceleration? And then the new graph is force, a net force graph. Show me in this scenario where the force was. The next one is going to be to turn the fan off. So no longer hovering, you will give it a push. Same thing, origin before the push, so probably not moving. Then you'll give it a shove, giving it some velocity, and then you'll graph what happens after the shove. With the fan on, give it a push, allow it to bounce off the wall. You'll need a wall it can bounce off of, but same idea. Set the origin just after it's released and after the bounce. So you'll give it a push, and you're starting with it already in motion. It'll hit the wall. What will that mean for its velocity? What will that mean for its acceleration? The last one, you're going to try to give a constant force to the hover ball. Even if you can't quite pull it off, show me what that will mean for the velocity, show me what that will mean for acceleration and force. When you're done, just make sure you turn them off, put them in the back of the lab where you found them. We'll go over it tomorrow. I expect that I am at home sourly recovering from my wisdom teeth operation, and I should be able to give you an update on that Tuesday because I plan on being in tomorrow. Can't say for sure, but that's my plan. So I hope everybody has a fabulous Monday. I hope you have a fabulous Wednesday too, but the Monday's more important right now.